Okay, so 2.4, we're starting with dividing polynomials. So one thing about this section is that we want to like go back a little bit, right? Because everything starts from some basic math concept. So dividing is our basic math concept here. So we want to look at when we divide using long division. Okay, so we just want to see if we remember about how to divide using long division. So let's do 2 divided into 452. So the steps of long division say divide. So 2 divided into 4 will go 2 times. Then we do what? Multiply. So 2 times 2 is 4. We subtract. And we do what? We bring down. And then what do? We start over. Divide. 2 divided into 5 would go 2 times. Not right. 2, 2. We'll go 2 times. 4, 1, 1, 12. So we've gone through our process. 2 divided into 5. Then 2 times 2, 4. We subtract. We bring down. Okay? So now we're starting again. 2 divided into 12 is 6. 6 times 2 is 12. So we've multiplied, we subtract. There's nothing to bring down, so we're finished. A process of long division. Well, then there's a process of division when we're dividing polynomials. So let's look at this. Divided by x plus 3. So when we're dividing polynomials, we have to divide when we're dividing by something that's not a monomial. We have to actually use long division to divide it. So we would have x plus 3 outside, x squared plus 10x plus 21. So when we do long division for polynomials, it is still the same process. We divide first. So you divide by your leading term only. So x divides into x squared. So x. And then what? Multiply. So x times x. And then because you have a binomial, you have to multiply it to each component. So x squared, or each term. X times 3, so 3x. Then we do what? Subtract. So you change everybody's sign. So 7x. And then we bring down. Plus 21. Yes? So then we do what? Start over. X divided into 7x is a 7. Then we multiply. 7x plus 21, subtract, everything cancels, no remainder. So x plus 7 is the answer. Well, what are we doing when we are dividing? We are trying to just figure out what can I multiply x plus 3 by to create this trinomial here. And we can multiply x plus 3 by x plus 7, and that would give us the trinomial that we were looking for, right? So that's what we're doing when we're doing long division. So what happens is nobody ever remembers how to do long division, and no one ever likes long division. And so they came up with something that is called synthetic division, which is what? Fake division, right? Synthetic, fake division. So they come up with a shortcut, essentially is what it is. And then when there's shortcuts, there's more rules to learn, and well, it is what it is. So synthetic division. But synthetic division allows us to divide without worrying about the variable components. So let's look at the problem that we already had. We had x squared plus 10x plus 21 divided by x plus 3. So with synthetic division, first of all, you create what is called a shelf number. Your shelf number comes from the divisor. So in our particular example, the divisor is always what you're dividing by. So x plus 3 would be our divisor. So the shelf number is the C. The shelf number is called the C. So the divisor is always of the form x minus C. So the divisor is always of the form x minus C. So if our divisor is of the form x minus C, and we have to identify our shelf number. So you create a shelf. It's a little shelf, like a backwards down. And that's where you're going to put your C term. So my C is from x minus C. So if this says x plus 3, but the divisor is always in the x minus C format, what does that mean? That means that my C is really a negative 3. Okay? Because what creates a plus 3 if your format is in x minus C? That means that you had a double negative. So, or you can just take the opposite, okay? So my 3 in the divisor is a plus 3, so if it comes out as C, it's going to be negative 3. Then what you're going to do, you identify your shelf, then you're going to list all your coefficients. So you're going to list your coefficients from your dividend. And the dividend is just your polynomial that you're dividing, okay? So in this case, it'd be 1, 10, and 21. So I have a shelf. And then I have a list of my coefficients that go across the top row. Okay? All right, so here's our process. The first value comes straight down. I'm going to multiply that value to the shelf. So the first value comes straight down. I multiply. So 1 times negative 3 is negative 3. So that product is going to go in your subsequent column. And then you're going to add down. So 10 plus negative 3 is a 7. Then you start your process over again. Multiply it to the shelf. So 7 times negative 3 is a negative 21. So that product goes in the subsequent column. Then you add down. 21 plus negative 21 is 0. So I get a 1 and a 7. But I want to make this clear. We already did real division. Real division is long division, and we got x plus 7. We know what the answer is supposed to be. We're trying to use this shortcut method, this fake division, synthetic division. Why is the answer not coming out the way it's supposed to? Because synthetic division allows for you to divide without having the variable components present. So when you get your answer, you are only getting the coefficient answers for your polynomial. So you have to put the variable components back into it. So we divide it. What's going to happen is when you divide, you are always going to realize that you are literally dividing some x into another x component. So you are always going to start your answer 1 degree less than the degree in the dividend. So because my dividend was a squared, this is going to start out as 1x plus 7. I just go down in order, which is essentially the same as saying x plus 7. So because I started as an x squared, my answer is going to come out as an x. If it started as an x cubed, then my answer would come out and start as an x squared. Okay, so that's our synthetic division. Let's look at another one. Okay, so here we have 4x cubed minus 3x squared plus 3x minus 1 being divided by x minus 1. So we're using synthetic division to divide this, okay? We don't have to do long division at all, right? We just look at long division just so we can understand that it really just builds, okay? It really is just basic long division, then you include polynomials in it, and nothing changes in the process. But we have this other method that we can use, synthetic division, which really makes it a lot easier to deal with dividing polynomials, okay? And it's going to help us further in the chapter. So synthetic division, we're going to first identify our shelf number. So we look at our divisor, which is x minus 1. So our shelf number, if it's in the x minus c form, then the shelf number is c. So therefore for this, our shelf number is 1. So our top row, we take the coefficients from the dividend. So 4, negative 3, 3, and negative 1. And then we start our process. So the process begins where the first number comes down. So bring down is first. Bring down. All right, so you bring down that first coefficient. And then you multiply that number to the shelf. So 4 times 1 is 4. All right, so my product goes in the subsequent column. Then you add down. So bring down, multiply, product, add down. All right. All right, so negative 3 plus a 4 is a 1. All right, so then we start again. Multiply to the shelf. 1 times 1 is 1. Then we add down. 3 plus 1 is 4. And then we start over. 4 times 1 is 4. We add down, we get -1 plus 4 is a 3. All right, so there's nothing left for me to bring down or do anything with, okay? So now all we're going to do is we're going to write up our answer. So if this started as a cubed, that means the first coefficient must start as the coefficient of a squared. So 4x squared plus 1x plus 4. So now I'm at my constant term. I have this last term here, this last value here. That 3 is going to be considered the remainder. So remember, there's sometimes that we divide and we end up with something that's not a zero remainder, right? That means it just doesn't divide evenly into that dividend, which is fine. And so how do we write a remainder as grown-ups, not as R3, right? That's very elementary. So we're in college algebra, so what do we do with a remainder? So let's just go down prerequisite lane for a second. And let's look at a fraction, 3 over 2. 3 over 2 is considered an improper fraction. So if I wanted to make that into a mixed number, we would divide the bottom into the top. So when we do that, 2 goes into 3 one whole time. 1 times 2 is 2. I have a remainder. How do I write the remainder, though? So when we are changing an improper fraction into a mixed number, the remainder becomes the what? The numerator of the fraction. So 1 and 1/2. That process is still applied in everything, essentially. And so if 3 is considered the remainder, 3 is going to be written as the numerator over the divisor, just like it is when you convert an improper fraction to a mixed number. And that would be your final answer. All right, so here we have 5x cubed minus 6x squared plus 11 divided by x minus 2. So first we identify our shelf because we're doing synthetic division here. So our shelf number would be 2. Then we identify our coefficients that go across the top. Now, this is important. When you look at your polynomial that you're dividing into, everything is supposed to be in descending order. When you are dividing, you must account for all terms in order. So when we look here, this goes from x cubed, x squared, and then it goes straight to x to the 0, which no x at all. So there's a term missing in this problem. So when we're missing a term, we have to account for it by holding the space with a coefficient of a 0. So 5x cubed minus 6x squared plus 0x plus 11. You cannot divide without all place values being accounted for. So we must hold that empty space for that x term. So when we write this, we're going to have 5, -6, 0, and 11 as our list. Okay? And then we go through our process. So the 5 comes straight down. Then I start multiply. 5 times 2, 10. Add down. 8. 16. All right, so when we write our problem, because it started as a cubed, this answer is going to start out as squared. So 5x squared plus 4x plus 8. And then my 27 is going to be my remainder. So I put it over the divisor. And that's it. So that's dividing using synthetic division. So just make sure if you're missing an exponent term, you must account for it by holding the space with a 0 and still go through your synthetic division process. All right, so that's 2.4 part 1. So that homework will be just synthetic division. So practice that.